This is video number 21 for the 3D Experience CATIA's generative shape design application. At this point, I have two playlists for this particular purpose. One of them is called wireframe playlist, wireframe app basically playlist. And the other one that this video is going to go to is the surface tab playlist. Sweep is one of the more advanced, or one of the advanced options in generative shape design, creating surfaces in generative shape design. It's more complicated than something like maybe revolve or extrude, because there's so many options that can be used, and not all of these are well explained in the help, and a lot of it has to do also with experience and the artistic view of generating a surface. Okay. Uh, when you select the surface tab, this ribbon appears at the bottom of the tree, at the bottom of the screen, and you have access to sweep by clicking on this sweep icon. Now, when you click on the sweep icon, this dialog box opens up, and notice that, first of all, on the top profile type, there's the first one, which is called explicit. You can draw anything you want, it's your own graph. This one is sweeping a line, and that is sweeping a circle, and finally a conic. Okay. Now, when you look at, for example, the explicit one here, there are certain subtypes that we're going to be later on using them, but maybe quite a few videos individually doing these things. But right now, it's a general comments about the issue of sweep in CATIA, or 3D Experience CATIA. There is help. The help is to some extent okay, but it's not very much in detail. And I can tell you why, because some of these things were written maybe 25 years ago, something like that, 25 years ago, maybe even longer. And the help does not include the theoretical help. So not everything is spelled out in the help that average user is confronting. And therefore, some of these things are not only not documented in uh, the help, but also uh, not available in the public domain anyway, because a lot of people don't know they have left or they're gone. Anyway, so let's move on. When this is the explicit option here, profile type explicit. There is the one when you open it up, and these are the options, by the way, for the explicit. Notice that there's three possibilities here. Uh, for the line, there is, I believe, 7. For the circle, you have another 7. And for the conic, you have these 4. Altogether, there are 21 possibilities of selecting one of these icons with one of these options. And we'll try to do one for every option. Now, there's also a lot of stuff down here, but these are optional things, which are important, but not everybody uses these optional choices for every project. Okay. I want to say a few words about this issue of sweep. The best reference that I came across is the instructor's guide. And this document is probably 25 years old. Instructor's guide for surface design. Essentially, when you are sweeping, you have a profile. Here's a profile. You have a spine, and you have a guide. Now, these are used loosely because, for example, in a particular problem, you may have a guide, you may not have a spine, and it turns out, for example, that guide is used automatically as a spine. The moral study is this: you have a spine in general, you have a guide, and you have a profile. So the way it works in the nutshell, with all the details that you need somewhere, but it's kind of hard to find them. Uh, it, this spine is divided into a lot of points. Think about it like that. And at each point, a normal to the spine, a normal plane to this spine line, spine curve is generated. So what you see here is these these green planes that you see here are normal planes to different point, many points on the spine. It's drawn here. Now, uh, the profile, there is a profile, presumably on one of these planes, maybe the first one, and then this profile is repeated on all of these planes uh, with respect to this spine. You can see that, for example, in this case, it's easy to explain. If you look at the profile on the first plane, whatever that distance is, hypothetically, whatever distance is, on the next one, you do the same thing. On the next one, you do the uh, this is only in a simple situation. Only you draw the profile, same distance to the place where the plane is intersecting the guide. And this is repeated. And all these things are connected, all these surfaces, all these uh, tiny little surfaces are connected together as you go through plane to plane to plane. This is the nutshell what's going on. So sweeping a profile along a guide curve with respect to a spine means planes are calculated, profiles are repeated on all these planes, you can see that, and a surface passing through these profiles is generated. It's a very loose way of saying it. And a lot of details hidden there, which is not available, at least to me. Okay, so let me repeat this. 3 steps explain the internal computation of the surface. When a profile is swept along the guide, to generate the surface, sweep internally computes planes normal to the spine along the guide curve. Okay? That's exactly those planes that I showed you. The profile to sweep is repeated in all the planes along the guide curve. Thus, the surface is generated passing through these profiles, which is normal to the plane at any point. See? Surface is generated passing through these planes, which is normal to the plane at any point. So, the shape of the sweep depends on the planes in which the sections are calculated. These planes depend on the spine because they all form normal to the spine curve. The shape of the sweep highly depends on the spine, but of course, not only that, it also depends on the guide and the profile. Spine is really the key concept to understand when we talk about sweep in CATIA V5, because the spine has an impact on the sweep shape and the sweep quality. Once again, I want to emphasize that in order to know all the ins and outs of what is happening when you get a surface generated on the screen for you using the sweep, you really need to know all the details if that happens to be of interest to you. Otherwise, you generate something, looks good, and just pass it on. An artistic viewpoint. Okay? We don't question what it is. We don't question how it is. etc., except for these very basic things that you can justify based on what we know. All right, so here's the situation. One more time. You have a spine. You have a spine and you have a guide and you have a profile. So at any point on the spine, there is a normal plane. The profile is drawn on that normal plane, okay? And uh, notice that that plane is going to be moved normal to the spine or in the green direction. The thing is that just saying that it moves in the green direction does not help, because this plane can also rotate, spin about that green axis. Okay. Of course, this green thing, this green line should not be there. That's a mistake. Okay, it can spin about that green line that you see there. This does not make sense, so I missed it. Okay, now the question is, so it's not uniquely defined. When we say move along the guide, what does it mean? In the direction of the in the direction of the normal to this plane, what does it mean? That is, for example, those three subtypes that I showed you in the initial slide. Okay, remember, with an explicit sweep, there's three subtypes. The subtypes were based on the surface, guide and based on the surface, two guides, and then a pulling direction, a guide and a pulling direction. Okay, so this rigid body spinning or rotation about that green axis that's hidden here. See that green axis in the back? This does not make sense. This green axis does not make sense. Is dictated, but which one of those three are using? Now, as I said, the choice of spine is important, because if there is a spine that has tangent discontinuity here, it affects the quality of the sweep. Notice that here it looks like our spine has some kind of a slope discontinuity, tangent discontinuity, and there is some defects that are generated, can be detected here, and uh, this can be that this can cause a problem. If this continuous tangent, things look a lot better. Okay. Now, here is the case of explicit sweep, and notice that these are subtypes with the reference surface, with two guide curves, and with pulling direction. Let me quickly tell you what this thing means. With a reference surface, that means that the orientation of that plane, to avoid it from rigid body rotation about that green axis, it could be that you say, oh, I want, for example, the vertical axis in that sketch to line up always with the normal to this reference surface. So that kind of fixes this plane, preventing it from rigid body rotation about that green direction. That green direction is the direction of the spine or normal to that plane. Okay? Or you can say that, oh, I want to draw that profile so that when I draw it, always goes through these two points, two fixed points. Okay, so that prevents the rigid body rotation. And finally, a pulling direction is just like the one on the very top, except that it is not normal to a surface. It's just some fixed direction. So once again, sweep is taking the plane normal to the spine, draw the graph on it, your sketch on it, and then move it normal to that plane, which is essentially along the tangent to the spine, but taking away the rotational effect that could have based on one of these three cases. Now, I'm going to put these things on the screen, but really one should think about it very carefully and read it, and put some effort into trying to justify, because some of the justification that you and I have may not be actually correct because it's not documented, and it gives it to you in a general framework, and overall you know what they're saying, but the details are important. The details could be important, may not be, depending on what your objective is. Okay. Uh, as we do examples, you see that these issues are going to pop up, and we're gonna try to look at different cases. Uh, for example, that as you sweep, the shape of that profile can change, and you can specify uh, anchor points. For example, in the case of sweep along two guides, may not be actually those two guide locations, maybe two arbitrary point that you're going to specify. Those are called anchor point, and there's a lot of options like that. And the positioning of a profile is extremely important. And this is one of the check boxes in the optional section of the dialog box. And you can actually literally move your cross section, your sketch to different location in space. And that's called profile positioning. There's a checkbox there, and you do it. You put numbers in there. But here you can see that position profile. All right, let me move on because we're going to do some examples. These are extremely important, some of them, and you can read it on your own. And this is a nice table from that instructor's guidebook and or presentation. And you can see that for sweeping, you need a profile. It can be explicit or it can be a line that's automatically done, or a circle, etc. You need a guide curve, and you need a spine. Okay. So this is the situation that we are dealing with. These are mandatory. We need to have it, but these X's are not applicable. There is a very good reference here. Unfortunately, it's not in English, but still it may help you. This is the CATIA V5 version of what I'm trying to do in 3D Experience CATIA, which is CATIA V6 essentially. Okay, and there's another good one here. This is in English, and but it's very short. I mean, this guy has an entire playlist, about maybe 20 videos on generative shape design for CATIA V5, but this one is fairly limited as far as sweep is concerned. There's only uh, two videos. All right. So that takes care of the general comments, and I hope it sheds some light on what we are doing. It's not straightforward, and not all of it is available in the public domain. And every software may have its own little ways of doing these things. If you go to Siemens NX or Creo or something else, you may have a different. The idea is probably the same, but the implementation is different. Good luck.